All right, hey, and welcome to Statistical Methods Exam 1 Review version A. So again, if you're joining us, then you know that it is in our online math resources course here. Just to remind you on some things, you click on Statistical Methods down here in the lower left-hand corner, and you go right over here to Test Review Materials. Open it up. And we are right up here at the top, review version A, the solution guide we are working on right now together. And the video is what we are working on right now together. After we are done recording this, it will be available to you. With that being said, if you want to look at this version that review that we're looking at, you can go ahead and download. But I already have the document up for us. So here's that same document. I know mine says version B, but it's really version A, I promise you. And I also have a document camera where you will be able to see me taking down the answers and writing up our solution guide. So I'm going to be jumping back and forth between those. I also have open StatCrunch and Desmos, both of which I allow on my exams. For other professors, you want to make sure about the Desmos, if they allow that or not. But StatCrunch should be available on all statistical exams for you. And you open it up the same way that you open up StatCrunch from assignments and quizzes. It is no different. With that being said, let's get this party started. All right, question number 1. And this review is 25 questions. Here we go. So question number 1 says, how many variables are there?
Nine.
I agree. There are 9 variables. How do we know that? Because it's like the questions that are being asked on their survey. Are you male or female? That's 1 variable. What is your age? That's 1 variable. What is your eye color? That's 1 variable. So if you count across the top, there are a total of 9 variables. Moving on, almost kind of the same data, but again, a little bit different. You know, they move things around. So if we look at question number 2, it says the variable age, is it numerical or categorical? And then you got a multiple choice question. So what do you think? Age, numerical or categorical?
Numerical, because the values are numbers.
That's right. Although remember with numerical, just because their numbers are actually, when your values are just because they are numbers, doesn't always mean it's numerical. Okay. Think again with numerical, when you have numbers, think of it, is this a measurement? Because numerical values are often measurements. So age is definitely a measurement in years. What about handedness? That's part B. Numerical or categorical?
Categorical.
Categorical. Because what? Why?
Because they're categories.
Because they're categories, right? You're either right-handed or left-handed. That's a category. So both of these, the answer for part A and the answer for part B, are both B as in boy. Okay. Yeah. Now remember, categories can be like what happened right here in these first column. These are numerical values, but those are coded numerical values. Or they are numerical values, but these are coded categorical values. Okay. 1 representing male and 0 representing female. So categorical data can be coded as numbers. So just keep that in mind too. We could do that with right-handed, or we can do that with handedness and code this according to 1s and 0s as well. All right, so part 3, or not part 3, question 3. The accompanied data was collected. The column heads give the variable, and each row represents a student in class. Hey, look at this right here. Sometimes if you forget things, later questions in your exam tell you how to locate things, like the column heads give the variable, It relates right back to question 1 if you forgot what a variable was. So they want us to code handedness using right-handed as the label. And they want to know how many ones and how many zeros will there be. So this is according to right-handed. So if you are right-handed, which value will you be, a 1 or a 0?
1.
You will be a 1 because the title of this column will now be right-handed. So that means if you're 0, you are left-handed, right? Yes, Mr. Armstrong. Absolutely. All right. So now that we know how the coding is going to go over here, how many ones would we have?
4.
We would have 4 because there are 4 right-handed students. So 4 goes in the first blank. Then how many zeros would we have?
5.
5, because we have 5 left-handed. And there you go. So the first blank would be 4, the second blank would be 5. Any questions so far about these tables of data and variables that we've been looking at? Again, all this is really coming from chapter 1. Okay. So question 1 through 3 so far from chapter 1, and so is question 4. I'll tell you what chapters are what as we're moving along through these. So we're still in chapter 1. So right here, it says a student shared data from StatCrunch friend data application, data on gender and the number of wall posts for a sample of friends are shown. Okay. So they want to know first, is this data stacked or unstacked? Oops, close. Shouldn't have been on anyway. So is that data stacked or unstacked? You are correct, Ruben. It is stacked. Because what's the difference between stacked and unstacked? How would
Because
we, sorry,
yeah.
go on.
If,
No,
if
no,
it
go on.
wasn't if it wasn't stacked, you will have one column for males, one column for female, so on and so forth.
That's right. Yeah, if we unstack this, we would have one column that dealt with males and their wall posts, and one column that dealt with females and their wall posts. Within this data, we have 2 sets of data that we're really looking at, males and females. So stacked data combines it all into one. But unstacked data separates them into their groups, like males and females. So right here, we know that the data is stacked because each blank, and I have a couple of reasons here. Each row represents one person of interest / column so one person of interest. A column represents one person of interest, or each column represents one post / row represents one post.
So I know it's the row represents one person of interest, but I always get confused because I know that both unstacked and stacked data are each column represents a variable, right? But it's in the row that it differentiates.
Mhm.
And what's that difference?
Yeah, and you're getting it. It should be the row represents one person of interest as the answer. Because if you do this one, the column represents one person of interest. This column is not about one person. Okay, this column right here is about all the males and females. It's not one person. So that's why
Correct.
this middle one doesn't make sense. The column represents one post. Well, this column doesn't represent one post. The row represents one post. This row doesn't represent one post. Okay? Each row represents one person of interest.
So for stacked data, each row represents one person of interest. And for unstacked data, what does each row represent? One variable?
So, and that one, it would, in this case, each row would represent the one post.
Oh, okay.
One.
So this is, so what is so this is, the format that it's stacked because each word, I missed that.
Because each row represents one person of interest. Let me do something real quick. So part B, explain the coding. What do the ones and zeros represent? So in the male column, the data value 1 represents a blank. Student who does not post, student, female student, student who posts, male student, wall post. So what do these ones represent?
Male student.
Male student. So that's the first blank. Second blank. And the data value 0 represents a male student, female student, student who posts, student who does not post, student, wall post,
Female student.
the female student. Perfecto. And then part C. So if you notice in part C, notice it says, if you stacked in part A, then unstack the two columns. If you answered unstack, then stack them. So which one are we gonna do for part C? Are we gonna stack or unstack?
Unstack.
We're gonna unstack. Okay. So here, they want to know which one of these displays is the unstacked information. Well, first off, which two displays are unstacked?
B and C.
B and C. All right. Now the question is, we just got to make sure that we have the right amount of numbers for each one. So which one of these is obviously off? Thinking about what we have right
C.
here.
C.
C. Why is C off?
Because they have 1, 2, 3, 4, 5 female categories, and there's
Yeah.
4.
There's 5 female pieces of information right here, but up here we only have 4 females. So by process of elimination, the answer must be
B.
B. Any questions about number 4? Okay. Part 5, a little bit of math here, just a little bit, not a lot. So it says a statistic class is made up of 12 men and 20 women. What percentage of the class is male? And we're gonna round to 1 decimal place. So what would we do here? I've got 12 men, 12 women. Twelve males and 20 females. Make sure of that. Yep. Okay. We want to know the percentage of men. How do we figure that out?
First, we would add the males and females so we know the total.
What is the total?
32.
Perfect. Because we add the males and the females. Okay. Now what?
Then we would divide the male. So 12 divided by the total, which is 32.
Mhm. And then I always related this to a proportion because proportions are very important for us. And we're looking for the percentage, right? And what is the percentage out of?
100.
100. So this is how I always set it up in class. I always related it to a proportion. Okay. But yes, we could divide the 12 by the 32. And then what are you going to do with that answer?
Multiply by 100.
Multiply by 100, which is the same thing that would happen when you cross multiply over here and get to the answer. Okay. Because if you cross multiply, you'd have 1200 equal to 32x, and then you would divide by 32.
37.5.
There you go. Percent is 37.5%. And we don't have to round because it already is at 0.5, right? Or did you round for me, Ruben, already?
No, I didn't.
There you go. Any questions over part A? I always like to relate it back to this proportion as your part over your total equals your percentage over 100. That's how these three problems really kind of play out. All right, let's do part B. Okay, part B. So part B says a different class has 289 students and 56.4% of them are men. How many men are in the class? We're going to round to the nearest whole number on this one. So we have 289 students. 56.4% are male. We want to know the number of males. So what are we going to do? And there are lots of ways to do this.
The way to do it is the 56.4% divided by 100, where I get 0.564.
Okay.
So it's 0.564.
Okay.
And then I multiplied that by 289, the total. And
Got it.
my answer.
That's the idea. Because again, relating back to this, we're looking for the part. We don't know how many males we have, but we do know that we have a total of 289. And if you do the cross multiplying and then divide by 100, you got your answer. Or as Catherine said, turn this into a decimal, multiply that number, and there's your answer. Now, again, you got to round to the nearest whole because this isn't going to come out nice and neat.
163.
163.
That's rounding at 163.
Okay. 163
Males.
males. And there you go. Part C. So part C says a different class is made up of 68% female or women and has 15 women or females. They want to know what is the total in the class. So what do we do here? And I believe this says we're gonna round to the nearest whole number. Yep, nearest whole number.
So what I would do, 68%
Mhm.
divided by 100, which is 0.68.
Okay. Then what?
So, okay, I don't write it like that, but
Okay.
so 0.8, and then the x is the total, which we don't know yet, and then is equal to 15 because 68% is 15 women,
Mhm.
and then I solve that equation.
You got it. Which is the same thing if you did this. We're looking for the total.
Mhm.
We know the part. So if you cross multiply, in the end, you'll end up taking 1500 divided by 68 to get your answer, which would be the same thing that you're doing, Catherine. You divide this and then you work it all out. It's the same thing. So again, lots of ways to do this, but I like to always take it back to the proportions. Because it's very much, you know, these percentages are related to proportions. And so are your class ratios. So what do we get? How many people are there total?
22.
22 females. And there you go.
Quick question, Professor.
Quick answer.
And this, just out of curiosity, I noticed that the 15, in this instance, the 15 was was on top and the X is at the bottom. And why in this particular question? For example, on the previous ones on the B,
Mhm.
if we cross multiply, it's 56.4 over 100. For example, X divided into 289, and then you cross multiply. In this instance, the 15 was on top, the X was at the bottom.
So remember that when we set up these kind of proportions,
Mhm.
that it's always a part to the total. So
Gotcha.
when you look at these, we were given the total here. That's how many students are in that class. That's
I
why the
see.
289 is at the bottom. Down here, we were looking for the total.
I
That's
see.
why the bottom is X. You had the part. Does that help?
Yes, it does. Can you focus on that formula you had with the part and
It's always the part
gotcha.
out of a total equal to your percentage out of 100, because percentages are out of 100.
Correct.
That's why they call it a percent part, which is the per, and then cent meaning 100.
Got it.
100. No worries. Good
Thank
question.
you. Thank you.
All right, moving on. A little bit of math right there. Still coming from chapter 1. Okay. So right here at question 6, this is going to end the chapter 1 information. So question 1 through 6 is all chapter 1. So it says indicate whether this is observational study or controlled. So a researcher is interested in the effects of music on memory. She randomly divides a group of students into 3 groups: those who will listen to quiet music, those who will listen to loud music, and those who will not listen to music. After appropriate music is played or not played, she gives the students a memory test. So what is this? What do you think? Let's just talk about observational or controlled first, and then we can look at the answers.
I believe it's a controlled.
Yeah, controlled.
Okay, so that narrows it down to either B or D. So B says this is a controlled experiment. She controls for other factors prior to assigning students to control groups and to treatment groups. This is essential to conducting a controlled experiment. D says this is a controlled experiment. She assigns students to control and treatment groups at random in order to control for all relevant factors aside from the effect of music on memory, which is essential to conducting a controlled experiment.
D.
Definitely is going to be D. The big thing is you need to make sure that you talk about it being random. And that's what this part right here was missing. She has control and two treatment groups, but she is randomly assigning people. And that's important for a control experiment. So it is D. Yay. Any questions on number 6? Okay. Any questions overall on chapter 1? Because that right there ends chapter 1. Okie dokie artichokes. Here we go with question 7. Okay. So question 7, we got a couple of blanks we're going to fill in. So here it says we got the resting pulse rate in beats per minute of a sample of 91 undergraduate students. And these were recorded. The data were displayed in the accompanying histogram and dot plot. Based on these graphs, would you consider a resting pulse rate of 60 beats per minute to be unusually low? Why or why not? So first, is 60 beats per minute unusually low?
Yes,
Why?
because on the frequency, it seems that the majority the majority is at 70 beats per minute.
Okay. Anyone else?
So what I did to confirm if it's lower or not, I would count the number of beats per minute that are below around 60, which are
Okay.
8. Then I divide that by the whole sample, which is 91, and it's only 8.8%, so it's less than 10%, which is low.
Okay, I agree. We're all gonna say yes to this. It is unusually low. Remember that when you're reading this histogram, sometimes the histogram can be a little deceiving. Sometimes, not always. When you look at these bars, granted 60 is in the middle here, but what is this bar really about? What does this bar represent?
So I get confused, but it represents also the 50 something, 55?
Mm-mm. Nope,
No?
this is
Okay.
not, this bar is not about 55. What is
About
this
8
bar?
people.
Huh?
8 people. 8 graduates. 8 undergraduate students.
Kind of, but what is the distance of this bar? Talk to me about the size of this bar. How many
Oh.
numbers does this span? Not the frequency. I want to know about what is this Ben? What does this Ben represent?
10?
A group of 10? That doesn't make any sense because over here is 10 away. How much is this Ben?
Is it from 60 to 64?
Yeah, it's about like 60 to 64. That's what this bin is about. What has this been about?
55
To what?
to
59?
60. To 60. No, to 59. Yeah, you're right. Sorry, 55 to 59.
Wow.
This is 60 to 64, 65, they throw it, it throws a little bit off. So that's why
Yes.
I'm saying the histogram might be a little bit tough to perceive. I like what Catherine said, going to the dot plot, because right here you can see where everybody is falling.
Gotcha.
And if you look at this, if you have a resting heart rate of 60, and technically I believe these dots should probably be over a little bit. As she said, there's only 8 of you that are down here that are really, really low. That's less than 10%. That's unusual. Because if you look at the rest of the dots, we're all up here
Mhm.
around the 70 mark. So that's why this answer has to be yes. I get more information from the dot plot than I usually do from the histogram. And so the answer is yes, because are we exactly less than or more than 10%?
Less than.
We are less than. Less than 10% of pulse rates were at most or at least 60 beats per minute.
I got confused on this question because they ask other ones, and this one is at most, right? Because at most means not more than.
Correct. Because
then-
this less than piece you're talking about is all of these beats per minute down here. And that's not at least 60, that's at most 60 beats.
And then what would at least mean?
So at least means you're at 60 or above.
Okay.
Right. Gotcha.
So you're talking about everybody down here that is unusual. And you're gonna go up to 60, but not pass it. So that's an at most. If you were gonna talk about an at least, you would start at 60 and go up here to all the way up to close to 100. That's not less than 10%. Think about the region you're talking about and then look at your numbers. You're talking about these 8 right here. So that means you go up to 60, but do not pass. If you were talking about all these, that would be an at least. Because you can be 60 or bigger. Does that make sense? The difference between at most and at least?
There's a minimum of 60.
Yes. The at least is like a minimum.
A
The
minimum.
at most represents like a maximum. Any questions on number 7? So the blanks go yes, less than, at most. All right. So the accompanying histogram is for pulse rates of 125 people. From the histogram, approximately what is the typical pulse rate in this sample? So the typical pulse rate in this sample is approximately 10, 90, 50, 70, 30. And again, this histogram is misleading. It's not really typically a number, but it should be a range of values. But they're giving us a choice here.
Wendy.
What is the typical value?
70.
70. And, they kind of get away with that by saying approximately, because approximately is like an estimation, meaning that you're around 70. So that's how they get away with not necessarily putting a full range of values because of that word approximately. But it would be better if they actually gave us a range of values, because that's what you're seeing on this is a range of values. Any questions on number 8? And again, if you look at these choices, there's a clear cut answer here. It's not, like something where that, oh, you can see kind of bimodality here, that this guy also was a typical value. And maybe that looking at this histogram, we probably have 2 sets of data that have been combined here. Maybe this represents males versus females, or females versus males, much like when hopefully in class, a professor showed you the example of the marathon runners, where we had Olympic runners and amateur runners, things like that. But this one, when it comes to the typical pulse rate, or when it comes to anything being typical, look for the largest bar. That's going to be your answer. All right, number 9, talking about the shape. So the accompanying histogram shows the distribution of the number of siblings, brothers and sisters for 2,000 adults surveyed in 2012. What is the shape of this?
Right skewed.
Right skewed.
Right skewed, definitely, because the tail is over here on the right side. Okay, so that's part A. Part B, what is the typical number of siblings? What is the typical number of siblings?
2 and 3.
2 and 3.
2
Let's
and
take a
3.
look at our choices. So it says 0 to 1, 6 to 7, 8 to 9, 10 to 11, 4 to 5, or 2 to 3. Which one of those is the best answer? Although I would say none of those are really the true answer, but that's just me. Going off of what we know based on this picture, which one of those is the right answer?
I agree with Ruben, 2 or 3.
2 or 3, absolutely. So the answer is B. But looking at this picture, what would be the typical answer though, according to these bars?
1 to 3.
1 to 3, or even I would almost go with 1 to 2, because these bars
Yes.
are really, really close. But I could see an answer for an argument for 1 to 3 as well, because these are typically the 3 highest bars. But I would want to see more closely what these numbers are for them. But again, they gave us a choice, and based off of our choices, this was the closest answer to what is really kind of typical. It says, how many people in this survey have no siblings? So what do you think?
I put C.
C?
Mhm.
So C says between 80 and 100. So if we look up here, this is definitely close to 100, but it's below it. So I would definitely go with C.
60. 80.
We're definitely somewhere probably between 80 and 100. I don't think we're as low as the 60 to 80. Because that should almost look like it's a little bit like almost halfway. And that's
Correct.
too low for this bar. You're on the upper end of this. All right, and then D, and this is going to relate back to kind of like what we talked about in part 5. So it says, what percentage of the 2,000 adults surveyed have no siblings? And what they want you to do is they want you to use your answer from part C on this. Okay, you gave us a range. Now we want to find those percentages. So how do we do that?
You're gonna take 80, well, the way I did it was 80 divided by 2,000,
Mhm.
0.04, and then times that by 100, which is 4. So that
Got it.
and then the same thing for the 100. You just do 100 divided by 2,000, which is 0.05, and then times it by 100, which is 5%. So
Perfect.
5%.
Or thinking about what we did in question 5, if you're thinking about proportions, this is what your proportions look like. Which is the same thing that Mariah just described in words. It's the same thing. Okay. So Mariah, give me those two percentages again. What was the 80 percentage?
It's
Four.
4 and 5%. Yeah.
So there's our first blank. There's our second blank. Everyone good on that? Makes sense? Our multiple choice goes A, B, and C. Okay. Moving on. Wrong one. All right, so we have a table of values over here. So this is where if you're definitely in the exam, you're gonna see like a little piece over here that looks like a window, a square or a rectangle on a rectangle. And that's where you can copy and paste directly in to your StatCrunch, which is really, really good. So real quick, says the accompanied table, which is this guy over here, shows the average lifespan for some mammals in years. Graph the average lifespans and describe the distribution. What is a typical lifespan? Identify any outliers and report their lifespans. If you were to include humans in this graph, where would that data point be? Humans average about 75 years. So the first thing we're gonna do is we're gonna go to StatCrunch, we're gonna create a histogram. It says our bin widths should be a width of 5 years, centered in 5-year increments. So that means what the centered means is that the multiples of 5 should be in the middle of the bar. That's what that means. But we don't necessarily have to do that. So let me take StatCrunch. I'm going to just slide this over onto my screen on my other computer screen that I have here. So that way I can see this table and put in my values real quick. So I'm going to need to put all these values right here in StatCrunch. So I'm going to call my variable lifespan. And I'm plugging in my numbers now, even though you can't see it. Again, you'll be able to do this much faster because you'll have that little box within a box over here. And when you click on it, it says opening in Excel, open in StatCrunch, or copy to clipboard. Just click on the open in StatCrunch and it'll take this information and shove it right into StatCrunch. 15, 8, 10, 12, 15, 40, 15, 41, 12, 12, 5, 12, and 25. So I had a total of 17 entries. Let me double check. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. Good. And just double checking my numbers. Again, when you just export this in or throw it into StatCrunch, your number should be right, but I'm typing in all my numbers. So I just doing a double check to make sure that once I run everything, we're going to be on the same page. All right, cool. And we should be now. All right. So here we go. Let me come here. Let me put my StatCrunch back where it goes. All right, so there it is, lifespan, all of our numbers. To make a histogram, we go to graph, scroll down to histogram, click on lifespan. And this is where you want to kind of play with this. I'm just going to start it at 0. And my width, they told us. So that's where right here, this part right here is important. Use bins with width of 5 years. Okay. So I'm going to go into my stat crunch. I'm just going to call this 5. Compute. So I'm really kind of looking for a table, a histogram that looks like this. Now, granted, my bars are not centered at 5 years, but even if I do center them at 5 years, it will still look somewhat like this. So if I go back to my answers,
Bless you.
excuse me,
Bless you.
I needed a bar graph that looked somewhat like what I had here. So notice I should have 2 spaces and it kind of looks like, excuse me, it goes up in the end. All right. So here are 3 of my graphs. Oh, there's only 3 graphs. Which one of these looks like what we had? Going back. So from my tallest bar, there should be a skip and a space, a bar, a skip, and then 2. And then 2 bars again with the last one kind of going up again.
I would say C.
And I agree that it is C. Okay, yes, these 2 bars are even, but remember the one thing I didn't do is I did not center these bars. But if I had centered these bars, these 2 would even up. Okay. So the answer is C. Good. Which question are we on? We are on number 10. Part A is C. Now the question is, describe the shape of the histogram. So what would you think the shape of this histogram is? Symmetric, skewed right, skewed left. What do you think? Our histogram is right here.
I would say B.
Definitely skewed right. There's a tail over here, even though it does go up a little bit. There is a tail. All right. What is the typical lifespan?
Between 10 and 15.
Between 10 and 15. Absolutely. Right in here. My 2 highest bars are right here, between 10 and 15. So that answer is A. So far we've got C, B, and A. Now, D says, are there any outliers? So up here, are there any outliers? What do you think?
I think there are.
Okay, do we know who they might be?
The hippo, the elephant, I would say A.
So the hippo and the elephant, just those 2?
No, and the Asian elephant, the African elephant, and the grizzly bear.
There you go. So coming down here, looking at this, definitely, I mean, when you're thinking about these, the choices down here, there's only one answer that really kind of makes sense,
Right.
you know, and that is A. Because based off of what we just answered in part C, these are around the typical lifespan. This one is around the typical lifespan that we just said. That's not an outlier if you're typical. So definitely A, because there are gaps. around these. Although I may not include the grizzly bear, but because we didn't learn about outlier formulas yet, we could say that the grizzly bear looks to be an outlier because there are gaps before we get to it and even after it. All right, and last but not least, if we included humans in this graph. So what's really cool, we can go back to this stat,
Right.
and I can add in humans, which they said is 75. And I can go back and refresh. Here are humans. So if I go back into this for part E, what does that do to us? Are humans typical? Are we way off to the right? Or will we be near the left of the graph?
Right.
Yeah, we're way off to the right over here. We're a huge outlier. So there we go. Part E is B. So going back through this, just to make sure that you know all the answers. C was the answer we chose for our histogram. Then we chose B, that it is right skewed. Then the typical lifespan is A, because we're between 10 and 15. Outliers, we believe, are these three bars that are right there, which consist of the grizzly bear, the hippo, the elephant Asian, or the Asian elephant, I should say, the African elephant. I think that was it. Yeah, those four. And then last but not least, if we were humans, we would be way off to the right, as you can see in our new histogram here, which was B. So C, B, A, A, B. All right, also know that in here, even though these are multiple choice, any of my multiple choice in here could be drop-down menus, just so you know. So it could be a rectangle that you click on and your list appears down below it, just so you know. There could be drop-down menus. All right, number 11. Look at this, we're almost halfway through. According to an organization, there are 5 leading causes of preventable death in a region. They are shown in the graph to the right, where high blood pressure, tobacco use, high blood glucose, physical activity, and overweight and obesity. So those are giving you the nicknames for them, the shorthand. All right, so we got questions A through, well, it says E, but I only see question D. So that's all right. I'll go back and look at this here in just a second, make sure everything gets answered. So estimate how many preventable deaths result from high blood pressure. And so this one, this is in chapter 2. So what we have just done is finished up like the first 2 sections of chapter 2. This is starting with section 2.3, where we're getting into categorical data. So we're still in chapter 2. So how many preventable deaths resulted from high blood pressure?
About 7.
About 7. Okay. And it does say round to 1 decimal place. You're a little bit above 7 there. So they're actually wanting you to give us a decimal here. What would you say that decimal would be for this?
7.1.
7.1. Okay. Their answer actually says 7.3, but I would think that that seems a little high based off of that chart, but I could see 7.1, 7.2. Just so you know. Their answer says 7.3. I think that might be a little high. But as long as you're around that answer, they should count it. I don't think you could say 7.0. I think we're definitely higher than that. So I would definitely put 7.1, maybe 7.2. Okay. So that's part A.
Is that gonna be like a fill in the blank on your own? Or
Yep.
is it gonna like give options?
Nope, that's gonna be a fill in the blank.
Mm.
Part B. The ones that have options are the ones on here that have options. So anything that has multiple options, like what you've been seeing, those are gonna be the ones that are multiple choice or drop down. If it actually says rounding, then on the exam, it's rounding and you are filling in the blank. Yeah. All right, so estimate how many preventable deaths result from tobacco use. Again, 1 decimal.
I mean, it says 1 decimal, but I really see it as 4 million.
And what would the decimal part be to that if it is exactly 4? 4 point what?
4.0.
4.0. Slap that O in there. Just for caution's sake. So if it is a decimal, I mean, if it is a nice solid number and it says, give me a decimal, I would put the 4.0 in there.
Would it be counted as a wrong answer if I don't?
It's a good question. If you run into that on the exam and it counts it wrong, let me know. I'm always
Okay.
willing to fix things that are silly.
All right.
Okay. But whatever decimal place it says, I would always round to that decimal place. So if it means I have to put in a, a position of 0, I put in a position of 0. And later on, yes, they will want those zeros and things like that.
Because
Just
I
so you know.
did like on the homework, sometimes I think it was like a similar question like this,
Mhm.
and I put like a 5 or like a 4, and it did count it good,
Okay.
even though the decimal. But
I
yeah,
always err on the side of caution, just in case.
yeah.
All right, so does this graph support the theory that the greatest rate of preventable deaths come from overweight and obesity? So does
No.
this graph support that? All right, so
No.
the answer is no, because right over here, it's the smallest bar.
Correct.
Okay, so we're gonna say for part C, no.
No.
Okay, so that's our first blank. The graph does or does not support the theory.
Does not.
Does not. That's our second blank. So you see how you have choices here? This is like a drop down. Okay. Or it could be a multiple choice, but most likely it's a drop down. Okay, so the graph does not support the theory that the greatest preventable rate of death comes from overweight and obesity, because overweight and obesity blank the greatest number of preventable deaths. Do not cause or cause.
Do not.
Do not. They are a cause of preventable deaths, but they are not the greatest. That's why we say do not cause, because it is not the greatest. So our first blank is no. Our second blank is does not. Our third blank is do not cause. And last but not least, this bar chart has a special name because of the decreasing order. What is it?
Perot chart.
Perot chart. So the answer is A. It is a Perot chart. Whenever you start at the highest and work your way to the lowest, that is a Perot chart. So there really are only till D on this. That shouldn't say E, should have been D, but that's okay. All right, right here, it says the accompanied table gives the percent of market controlled by the most popular internet browser in 1 year. Sketch the appropriate graph of the distribution and comment on its important features. So they want to know which graph or one type of appropriate graph for showing this as a bar chart. Which of the following bar charts is the correct distribution of this?
D.
D?
Mhm.
What do you all say? You agree?
Which one?
They want to
Oh.
know which bar chart right here displays this information.
Yeah, it's D.
It is D. And right away, you can tell that. I mean, browser 1, 59. That's not 59. That's not 59. That's not 50. Oh, D has to be the answer. Some of these, they make the choices almost like really, really obvious when you just look at the data. D is the only one that has browser 1 close to 59. Okay, so here's what our chart looks like. Which of the following would also be appropriate graphs for showing the given distribution? A dot plot, a pie chart, a stem plot, a histogram, a Perot chart, none of the above. So this question is going back to what kind of data do we have here?
Numerical.
Is it?
Categorical.
This is categorical because you are separated into different browsers, different companies like AT&T, Google Fiber, things like that. These are different companies. So this is very much categorical, even though it looks numerical in nature because of the kind of coding that you see right here. So I only need displays that are categorical in nature. Who are they? Perot chart. And who else?
Pie
Yes.
chart?
There you go. The Perot and the pie chart. Because this is categorical data. And we use the Perot and pie chart for categorical. The dot, the stem, and the histogram are for numerical data. Part C. Which of the following is the best description of the distribution's important features? Browser 1 and 3 share the same market share. Browser 2 controls the highest market share. Browser 1 controls the highest market share. Browser 2 and 4 share the same market share. So what do you think? That's what it looks like. There's what we're saying.
D. Browser
D.
1 controls the highest market share.
That's right. Whatever company browser 1 is, they're killing it. And that's what we got down here. That's the only answer that makes sense. Because 2 and 4, the 2 bar is higher than the 4 bar. 1 and 3, they're not the same because 1 is a huge bar, 3 is a low bar. And then 2 is the highest. No, we just said 1 is the highest. So these other answers just don't make no sense. Don't make no sense. All right, moving on. So we got a graph here that shows the distribution of data on whether houses in a large neighborhood have a garage. 1 indicates a house has a garage. 0 indicates it does not have a garage. Is this a bar graph or a histogram? And then the question is, how could the graph be improved? What do we have here?
I think it's a histogram.
Why is it a histogram?
The bars are touching.
The bars are touching. That's it. Even though the data is categorical. These are coding right here. This is a histogram because your bars are touching. I know it's so weird, but it is a histogram. So that's part A. The answer is B. And again, just because the horizontal axis are numbers doesn't always mean it's a histogram. Okay? Because we've had numbers up here. Oh, look, numbers, but my bars aren't touching. This is not a histogram. This is a histogram, bars are touching. Okay, it's not a bar graph because it does not matter which order the bars are placed in. Normally, if we do numbers and coding, we always start at the smallest code and work our way up to the largest code. So it does matter. And then the bars show each observation category. That is true, but my bars are touching. That's why it's a histogram. That's the big key. When your bars touch, you're looking at a histogram. All right, but how could we improve this? So the graph could be improved by containing more categories. Like what if they have a 2-car garage or 3-car garage or 4-car garage? The graph could be could improve by making it a bar chart or pie chart. This would make the variable garage be more be seen as categories and not numbers. Could be improved by switching position of the car categories. Would make it from the most frequent to the least frequent, changing it to a Perot chart. Or could be improved by changing the units on the vertical axis to relative frequencies. Which one is the better improvement? Again, think about the data we have.
B.
It is B. A histogram is not an appropriate graph to be using for categorical data. This data is categorical. This histogram was inappropriate. The way we should be displaying this is in a true bar graph or pie chart so that we can see it as the categories it is. Perfect. So both of these answers are B. Both of these answers are going to be B.
Professor?
Yes.
Okay, so even though if they're like coded, it doesn't make it numerical, right? Like the categorical data.
Yeah,
Just-
even though this is coded, it is a histogram, but it's still categorical data anyway.
Okay.
It's
Thank
still
you.
categorical.
Mhm.
Yeah. Good question. Yeah, that doesn't change that. Again, like I said, this is an inappropriate graph to show. We don't want a histogram for categorical data. All right, right here, 14. So we got a pie chart showing the number of hours of sleep last night for 121 college students. Which would be a better type of graph displaying these? All right. So this is all the number of hours slept for students. So again, this is a lot like what we talked about in 13. This is an inappropriate display. How can we make it better?
Histogram
Mm-hmm.
or dot plot,
Mm-hmm. Why?
because number of hours of sleep is numerical, not categorical.
You got it. This is all numerical data over here. This is measurable. Okay, this isn't categories. And also, if you look at this, I mean, this pie chart is pretty busy. And if you don't look carefully, you might almost miss this tiny little sliver of gray that's right here for someone that slept 10 hours. Okay, not the greatest chart because pie chart should be used for categorical, not numerical. So I do like that we said a histogram because that is for numerical data, and that we said a dot plot because again, that is for numerical data. Why is the pie chart hard to interpret? So the colors chosen for the chart are too similar, hard to tell slices. The sample of students is too large, causing too many different results. The pie chart shows the proportion of students who got a certain number of hours of sleep, not the frequency of the students. There are so many possible numerical values causing the pie chart to have too many slices, which makes it difficult to tell which is which.
D.
Say it again.
D.
D. It is D.
Sir, why not the other ones? I feel like some make sense, right?
You feel like some make sense. Well, let's talk about each one of these. But the true answer is D. Because there are pie charts get way too busy when there are too many possible answers. Okay, this pie chart is way too busy because of all the different types of answers here. Pie charts are better suited when there are, maybe 4 or 5 slices or less. So in here, the colors chosen are too similar. All of these are different colors and they're not really similar. I can distinguish every piece, even though this slice is pretty small. But I can still see that piece, right? I can see every slice and I don't have colors blending together. Does that make sense?
Yeah.
Like if this was more yellow next to this yellow, that might make difficulty. So it's not the colors that are a problem. So the sample is too large, causing too many different results. I can have a large sample and have a pie chart look just fine for large samples. So in this one, it's saying the problem is because the sample is too large. No, that's not a problem. Because I can have a large sample and have few data entries or possible answers. Does that make sense?
Yeah.
So, I mean, like I could do this large sample and have this, put into categories too. I could have like a range of values and that would clean up my pie chart. And I could still have a large sample. So it's not the sample size that's a problem. The pie chart only shows proportions of students who got a certain number of hours of sleep and not the frequency. I mean, technically from this, this one, it doesn't matter for us. Okay, it shows the proportion of students who got a certain number of hours of sleep. All right. So that doesn't make this hard to interpret. I know which ones, I can look at this and I can know what the typical value kind of is. What is the typical value based off of this pie chart?
Green?
For anybody. Look at this pie chart. What is our typical value? Who has the biggest wedge?
The 7.5 or 7.0, I'm sorry.
7.0, yeah. So it's a 7.0. So I can still interpret based off of those slices. I don't need the frequency of the students to know information. Does that make sense?
Mm-hmm.
So it's not that. The part that's the problem is because we have numerical values and we have a ton of them. There are too many slices up here. It's too much. That's the real problem. And again, also, this is numerical data in a pie chart. That's bad. Does that help, Catherine, kind of sort through these?
Yes. Thank you.
Based off of the colors, I can still interpret. Based off of the sample size, I can still interpret this. Okay, it's not because the sample size is too large. Okay, based off of the proportions, I can still interpret. What makes it hard to interpret is because there are so many slices. All right. Hopefully that helps.
It does.
All right, 15. Let me double check something real quick. All right, so 15 right here. This ends chapter 2. This will be our last question on chapter 2. So I think we started at what, question 7, was it? Or was it question 6? Let me double check. Question 7, all the way through questions 15 is all chapter 2. So once we get to chapter or question 16, we will then be in chapter 3. All right, multiple part question. So it says refer to the accompanied graph, which shows the time spent on a typical day talking on the cell phone for some men and women. Each person was asked to choose one of 4 intervals that best fit the amount of time they spent on the phone. So the intervals are like 0 to 4, 4 to 8, 8 to 12, 12 and on. So the first one is we're going to talk about the variables. So we want to identify the 2 variables and then state whether they are categorical or numerical. So one variable is blank: gender, number of users, number of cell phones.
Gender.
Gender, because none of those other 2 make any sense. Number of users, I don't have the number of users. Okay. Although we could probably kind of figure that out based off the top of the bars, but that's not what we have here. Number of cell phones, none of this is about the number of cell phones. This is all about hours spent on a cell phone. So these other 2 categories don't make any sense. Okay, so gender, is it numerical or categorical?
Categorical.
Absolutely. It is a categorical variable since it describes qualities or quantities.
Qualities.
Qualities.
I have a question on that last one with
Yes.
the number of users. Because when I first did it, that's what I chose, because number of users, number of people. Is it very specific on the test? Like it's gonna say number of users, not like insinuating.
Number of users, number of people, they would be the same thing. I could switch those words out, but one of your variables is not about the number of users or people. Because if you look right here, this is one of your variables, whether you're male or female.
Okay.
Think about the questions that are being asked for this.
Right.
You're being asked if you're male or female, and you're also being asked how many hours on the cell phone you spend. Does that make sense?
Yeah.
Those are the,
if
sorry, go on, Mariah.
I just didn't know, because I kind of chose both. I kind of bounced between the 2 for the first part, because gender, I can obviously see that that's a variable, but I also see number of users on the sidebar. So I didn't know if, because it says people, is that why it doesn't make any sense? Like, is that why those aren't equal? I don't know.
Again, I could put people here, but that still is not one of my variables.
Okay.
Think of this as number of people as frequency.
Okay.
Is frequency ever one of our variables? No, it's something that we get from our variables. It's a result of our variables. Does that make sense? So number of users, number of people, frequency, they're all the same idea on this. This is a result of our variables that we're asking.
Okay.
Yeah, good question. All right. So think about, like, when you're thinking variables, think about the questions that were being asked. In this one, there's a question about being male or female. And then the other question being asked was, how many hours do you spend on the cell phone? Those are your two variables.
Okay,
So the other variable is blank, age of user, type of cell phone, time range.
time range.
It is time range. Because again, nothing up there tells us the age of our user. Nothing up there tells us the type of cell phone. Which is a blank, numerical or categorical?
Numerical.
Eh,
No?
nope,
Is it
It's cat-
categorical?
it is categorical. Now let's talk about why. Because this one always gets me too. Usually when every semester I have to refresh myself on questions, and this is one I always have to like, oh yeah. Why is this categorical?
Is it because it's a range?
Because it's a range. You are being placed into one of these buckets. You're not telling me how many hours you are on the phone exactly. You are telling me you're in this range. You're in this range. You're in this range. It's like asking you, what's your favorite color? I'm putting you in this bucket, this bucket, this bucket. How many hours do you spend on the phone? Oh, you're in this bucket or this bucket or this bucket. Does that
So
make
if-
sense?
So if it would, yes. So if it would have been 0, 1, 2, 3, 4,
Mhm.
that would have made it numerical.
Yeah, if you actually know specifically how many hours they're on the phone, that's numerical. Because you are telling me the exact amount. You are giving me the measurement. I'm not getting a measurement here. I'm getting a range. I am somewhere in here. I'm somewhere in there. I'm with this cell phone company. I'm with that cell phone company. I like this color. I like that color.
So
I am
quantitative
I'm putting
quantitative
you into
data
a,
would be
sorry, go on.
numerical.
Ruben.
Will quantitative data be always
Yes.
categorical?
Um,
Always?
no, well, no. Quantitative data is not always categorical. Numerical data is always quantitative though. So in this one, because you are falling into ranges, you are falling into different buckets. That's what makes this categorical.
Hmm.
You are not telling me the specific number. So like up here, if I had ranges of hours of sleep, that would have been categorical. But in here, this is all numerical because you're telling me the exact number of hours you slept. Does that make sense?
Mhm.
This is all numerical. This is categorical. Okay. And it is categorical because it is describing a quality or quantity. It is a quality. Again, another way to think of this, Ruben, is if I said, instead of saying numbers, do you talk on the cell phone a lot or a little?
Myself?
Just in general, that's kind of the question they're asking.
Correct.
That's what they're
Correct.
asking here in general. They
Right.
just actually put some ranges behind that question.
So
I
is
see.
categorical always gonna be qualities?
Categorical should be qualities, absolutely.
All right,
Because the category describes characteristics about you.
Got it.
Absolutely. Categorical should be qualities. Because it's all
Got
about
it.
characteristics. Yeah, this is one question, be careful on, and it's really the second part of that question that gets you. If it is a range of values, you are falling into categories. If you are giving me an exact value, that's more numerical. Okay. All right. So is this graph a bar chart or a histogram?
Bar chart.
And which would be a better choice? So you say it's a bar chart. Oh, and which would be the better? Okay, yeah. So you said it's a bar chart. So that means I have three answers here. The graph is a bar chart. It is the better choice since both variables are categorical. It is a bar chart. It is a better choice since both variables are numerical. It is a bar chart. It is the better choice since one variable is categorical and the other is numerical. Think about what we just said in part A.
B.
It would be B. Because in part A, you said both variables are categorical. The other answers don't make any sense. My variables are categorical, not numerical. One variable is categorical? No, we said both. So the only answer that makes sense, it is B. It is a bar chart. It's not a histogram because my bars are not touching. All right, part C. If you had the actual number of hours for each person rather than the interval, what type of graph should you use to display the distribution? 2 bar charts, histograms, or dot plots? Which one should we use? So if we actually had the number of hours on the phone.
Histogram.
A histogram? Absolutely. I would go with a histogram. Because now I have made that data value what?
Numerical.
That variable numerical. That's right. So histogram should be used since the time would be what kind of variable now?
It's a numerical.
Numerical.
Would dot plots also be a complete answer?
Let's see here. Let's make sure I read the question. Man, it sucks that they put both of those on. I think the better display and what they're really trying to get at would be the histogram. So think in terms of the better display for this. So go histogram.
Okay.
Dot plot would actually be just as fine. But they're really asking you about like kind of bars. So go with the histogram. But a dot plot would not, technically a dot plot would not be wrong for that. Technically. All right, so it says compare the modes of the two distributions and interpret what we discovered. What does this say about the difference between men and women? So what is the mode for men? What is the mode for men, the males?
I was muted. It's 0 to 4.
It is 0 to 4 because that's their tallest bar. What is the mode for females?
4 to 8.
4 to 8. All right, so let's keep that in mind. All right, so we're going to come down here. The mode for women you said is 4 to 8. So that's the first blank. So the mode for women is 4 to 8 hours because blank. Its height is 0%. It is the tallest bar for women. Its height is 100%. It is the shortest bar for women.
Tallest bar for women.
You got it. It is the tallest bar for women. So the next one says the mode for men, we said was 0 to 4. And because its height is 0%, it is the tallest bar for men. Its height is 100%. It is the shortest bar for men.
So
Yep. Okay. Therefore, the distribution shows that women or men talk more.
women.
Women. So kind of going back through this one, because there's a lot of blanks in this, just to make sure everybody's got everything. So in part A, in order of the blanks, it goes gender, categorical, qualities. Then the last three blanks go time range, categorical, qualities. Part B, the answer was B. C, the answer was a histogram as the best choice. And the answer was numerical for the second blank. Although dot plot would not be a bad answer there, but they're looking for histogram because they want to look at bars. And then in part D, first blank is 4 to 8. Second blank, it is the tallest bar for women. The third blank is 0 to 4. Fourth blank, it is the tallest bar for men. Last blank is women. Talk more according to the distribution. And that right there wraps up chapter 2. So 1 through 6 is chapter 1. 7 through 15, chapter 2. From 16 here on through the end is chapter 3. All right. So 16 says the histogram shows the self-reported number of exercise hours in a week for 50 students. Without doing calculations, what is the approximate mean number of exercise hours for these 50 students?
So
So,
it's 4 to 6
okay.
hours.
So would that be C or D?
D.
It would be D. Yeah, it is 4 to 6 hours. Because remember, we talked about this, whenever you have skewed distributions. Okay. I don't know if it'll let me do it on here. Hey, it did. Skewed distributions. Remember that right here really kind of represents your median near the peak. And that because this is skewed right, my mean has been pulled a little bit higher. So my mean is somewhere around here, which is between 4 to 6. Okay. Because of this outlier here, it's pulling my mean, making it a little bit higher. So the mean is not going to be around that 2 to 4. It's going to be up around that 4 to 6. Does that make sense? So the answer has to be D. Because it is to the right of the peak because of the right skew.
The definition of mean is the average of
Yeah.
the exercise hours, correct?
You got it. If I averaged all of these data points, that's the mean. But because of this outlier right there, it's making my mean higher than what it should be.
I see.
So we got this table here. The table shows 100-meter backstroke and 100-meter butterfly gold medal times in seconds for 5 recent competitions. So we're going to complete part A. So we need to find some means and standard deviations. Okay. So we're going to go in, and again, over here, you would have that little
Icon.
box on, yep, that icon, that box on box, the rectangle on rectangle that you can import this directly into StatCrunch. So I'm going to open up StatCrunch real quick, and I'm going to input my data. Give me just a moment to do that. Delete out my old data. So I'm going to call this back, and this one butter. 53.4, 54.3, 52.4, 52.2, and 51.9. And then for the butterfly, 51.8, 51.3, 50.1, 51.4, 50.5. All right, pulling the data back over. So here's our data for the back and the butter. Where am I going to go to find mean and standard deviation? You guys remember?
Go to stat and summary.
Stat, summary stat, then what?
Columns.
Columns. And we'll select back and hit compute. And then we'll do that again. And then we'll select the butterfly. So stat, summary stats, columns, butter, compute. All right, now we've got information that we can fill in. Okay. So we've got our mean, which is right here. For the back, it's 52.84. For the butterfly, it's 51.02. And we have our standard deviation. Okay, so make sure that you are conscious about the rounding on this. It's going to be very important. So jumping back into our problem. Part A says that the typical gold medal time for the 100-meter backstroke is blank seconds. She made this multiple choice. It is not a multiple choice. Well, yeah, no, it is a multiple choice question. Okay. So what is the typical backstroke time? And then we got to choose which of these sentences makes the most sense for the meaning interpretation of it. And it does not say where to round. But looking at my answers, it has 2 decimal places. So which one of these answers are we going to go with?
Well, it says rounded to the nearest hundredth, right?
Oh, it did? Where did I miss that?
The last of the,
Oh, rounded to the nearest 100. Thank you. Good catch. Usually that's in parentheses or in that fine print. So good catch.
So Professor, quick question, because I think on the homework, I got it wrong, or on the quiz, I don't remember. Anyways, so it said to the nearest 100, and I had, I believe, only 1 decimal place.
Okay,
because it's 51.8 or something like that. And so I should have put 51.80, right?
did it count it wrong when you only put one decimal place?
Yeah.
This is what I was talking about, where those zeros, better safe than sorry kind of thing.
Yeah.
We're gonna talk about that on here. All right, so which one of these answers should we pick?
B.
B? All right. And what goes in the blank then?
The mean,
Which is,
I don't have
let's go back. What is the mean?
the mean for the back is 52.84.
There you go. Now, let's talk about why we're choosing B. Okay. B is the most descriptive of what we're looking at. Up here, this says the typical gold medal time for the 100-meter backstroke is blank. What this sentence is stating is that this is over all the Olympics. Did we look at all the backstroke times for all the Olympics? No, we're looking at the 5 recent competitions. That's why A is out. And C, it says the typical gold medal time for backstroke in 5 recent competitions. This is saying all backstroke competitions, because there's more than just the 100-meter backstroke. Does that make sense? That's why we have to throw this out, because our data is specifically about 100 meters. The last one. This is the typical time for the 100-meter backstroke. These are not typical times. These are gold medal times, which is why you throw the last one out. B is the one that describes exactly the mean we're looking at. It is the gold medal time of the 100-meter backstroke in the last 5 competitions. Does that make sense? All right. So part B wants to know what is the standard deviation. And again, you're going to round to the nearest 100th. So let's grab the standard deviation. Let's get that. What is the standard deviation for the backstroke?
0.99.
0.99. All right. So we come back here. Now the question is, which one of these is the answer for that?
Is it B?
It is B. And in the blank, 0.99. And I would include the 0 before the decimal. Okay. And again, that's because this is the most specific. Okay. Again, if we dissect this, A is saying for all backstrokes, 100 meter, 200 meter, 300 meter, and so on and so forth. That's not what we're dealing with. C doesn't, this talks about all Olympic 100-meter backstroking competitions, but we only dealt with the first 5. And then the last one, D, again, they messed up on the time. This is gold medal time. D is the only one that has all 3 pieces that we need. All right. C. So this one wants to know what is the mean for the 100-meter butterfly. So what is the mean? And we are rounding to the nearest 100th.
51.02.
51.02. Which one has the true description?
B?
It is B. Just like all the others before it, B has the gold medal time. It's the 100-meter butterfly, and it's for the most 5 recent competitions. And in the blank goes 51.02. And then D, and then we'll do a comparison. D. Let's go find our standard deviation, rounded to the nearest hundredth.
131.
6.70.
6, yeah, 0.70. This is one where the 7 says, hey, 9, go up and make this 70. So in the blank, you'll put 0.70. They want both decimals. This is when as I said earlier, err on the side of caution and put the zeros in all the way up to whatever decimal place they've been asking for. So put 0.70 in the blank for the whichever answer we choose. Err on the side of caution. So if we go back, which one of these answers is the best answer for the standard deviation for the 100-meter butterfly?
B.
B again. All of these have been B all the way down because Bs have had everything we needed. Gold medal time, 100-meter butterfly, 5 recent competitions. 0.70. And then now, using that information, we are on to the compare the mean and standard deviation of the 2 strokes. Which stroke tends to have a faster gold medal time? Which one has more variation? So who has the faster gold medal time?
Backstroke.
The backstroke. It does?
No, the butterfly.
The butterfly is faster. It's 51.02 seconds. It's faster. But who has more variation?
Backstroke.
That's the backstroke. The larger the standard deviation, the larger the variation. The smaller the standard deviation, the less variation. The less spread out your data is. So we're looking for something that says the butterfly is the fastest, but the backstroke has the more variation. So which answer is that?
E.
B?
No, E.
E? So E says the butterfly tends to be faster. Okay, so far so good. The backstroke tends to have more variation. Perfect. So part E is E. Any questions on that one?
Professor, what was it that you said that, can you repeat that again? The larger, the standard
Okay, so when you're
deviation?
looking at variation,
Mhm.
the larger the standard deviation, the bigger the number is, the more variation there is. The smaller the standard deviation, the smaller the variation. Means that the smaller your standard deviation, the more your data is clumped together. The larger the variation, the more it will differ. So if I'm thinking in terms of a symmetric graph, oh, man, let me highlight. Come on now. It's not letting me highlight it like I wanted to. There, maybe. Nope. Nope, not letting me highlight other than what I just did there. Darn. It's going to show you something. Actually, maybe here, it might let me do this. Nope, let's try something else. Just kidding. Oh, let me bring up something so I can do a quick draw. So standard deviation. If it is large, when you're looking at the spread of your data, it's kind of a more spread out curve. When your standard deviation is small, it looks like that in symmetric data, meaning more of my data is clumped together here, where up here, I don't have half as much data clumped together. So meaning that I'm more spread out here with a large standard deviation. I'm less spread out here with a small standard deviation.
Gotcha.
That's the idea.
What was the seconds, the timing on on question, section C?
Sure.
Just the timing on the 100-meter butterfly.
So here's all the answers. So part A was B, and then the blank, you put 52.84. Part B was B, you put 0.99. Part C was B, you'd put 51.02.
Got it.
Part D is B, you'd put 0.70. And part E was E. All right, 18. Oh, I'm totally in the wrong thing. Let's go to our exam. All right, so we got surfers. Okay, and we collected data about long boards and short boards. So we need to find, again, we're going to be looking for the mean and the median, or sorry, the mean and the standard deviation. So I need to go back to my stat crunch. I need to slap all this information in real quick. Again, yours will be much faster than mine because I can't just copy paste right over real quick. I have to do a little bit of finagling. So I'm going to call one of my variables long, the other one short, and slap in my 30 pieces of data real quick. All of this can be done on the TI-84 as well, just so you know. I think just Stat Crunch is a little bit more user-friendly in that matter and would be faster for you to use. This is the long part of your exam. If you're trying to put data in by hand, that's what's really going to kind of take you the longest when you do this. 11, 6, 9, 19, 14, and 15. There's 30 pieces there. Doing the short board real quick. 5. Appreciate you all being patient as I slap these numbers in the Stat Crunch. Almost done. Perfect. 30 and 30. Got it. All right, so all we're going to do in here, take our data that we have right here and do some quick summaries. So stat, summary stat, columns, long, compute. There it is. Stat, summary stat, columns, short, compute. All right, now we've got all of our data to answer the questions. So going back real quick. So the first one, I believe, is about the means. And you're going to round to 1 decimal place. So I need the mean for the long and the mean for the short. Let's grab that real quick. So what is the mean for the long?
12.6.
Yeah, no rounding there. We got everything we need. What is the mean for the short?
13.2.
Okay. So in that first blank up there, you're going to put 12.6. In the second blank, you'll put 13.2. And then now the question is, so blank tend to go surfing more.
Short borders.
Short borders, they have a higher mean. They go surfing more. So you'll say short borders. Okay. Part B, we need standard deviations, round to 1 decimal place. All right, so we go back into our data. What is the standard deviation for long?
5.58.
Careful, it said 1 decimal place this
Oh,
time.
5.6.
5.6. Watch those rounding.
Yes.
And what is the standard deviation for the short?
5.1.
5.1. Good. All right. So going back to our screen, our review, we'll put 5.6 in the first blank for long borders, 5.1 in the second blank for short borders. So blank tends to have more varied days. Who varies more?
Long borders.
The long borders, because they have a higher standard deviation. So to run down our blanks real quick, 12.6, 13.2, short borders, 5.6, 5.1, long borders. All right, scrolling on down. We're getting there, we're almost done. 19. So the accompanying histogram shows the number of runs scored by baseball teams for 3 seasons. The distribution is roughly unimodal and symmetric, with a mean of 688 and a standard deviation of 68. An interval 1 standard deviation above and below the mean is marked. So this is 1 standard deviation below, this is 1 standard deviation above, this is the mean. So let's talk about our information. According to the empirical rule, approximately what % of data falls between 620 and 756? That means 1 standard deviation. How much of my data is there?
68%.
68%. That's what they want. So between my 2 red markings here, that is 68% of my data. Between those 2 red markings. So part B, use the histogram to estimate the actual percentage of the teams that fall in this interval. Did your estimate compare to the value predicted by the empirical rule? So what they're asking you to do is take these values here, like the 32, the 34, the 27, add that up, and then divide by the total. Did that roughly come out to 68%?
I got this in the homework, and I have a question on this particular answer.
Sure.
On the homework, it showed, if we could go up on the graph,
Mhm.
it showed, okay, it showed, for example, on the 32, the 34 and 27 falls within the 68%. That's pretty much self-explanatory. On the 32, on the homework, it made that 32, they estimate at 21, right?
Sure.
And then a little bit after the 27, that little gap there, they estimated at 2. But I was never, ever, never able to find out how would you come up with saying, since it's not the full 32, it's a 21. And then the little space there between on the
Little
right hand
sliver.
side, yeah, little sliver is a 2. I wasn't
All right.
ever able to understand
So
that.
here's what you need to think about. So let's just say we take these 3 bars, since I'm not really going to count the 16 because there's a small sliver there, right? So let's take these 3 bars. If I add these 3 numbers up, that's 93.
Correct.
Okay. If I take the total, take 2 plus 4 plus all these numbers on top, there's 120. So if I take 93 divided by 120, jump over to StatCrunch, or not StatCrunch, but Desmos.
93 divided.
So what I did was I took the 32 plus the 34 plus the 27. That's where I got the 93. And then I added up all the numbers at the tops of the bars. Plus 16 plus 2 plus 3. There's the 120.
Okay.
So take 93 divided by 120. There's my percentage. Basically about 78%. Okay. Now, if I come back here and think about that. So what I'm saying is this is about 78% of my data. But technically I included way more than what I needed here, right?
Mhm.
So if I'm thinking about this, if I estimate this, how much of my percentage do you think is really there?
68%.
Oh. So we estimated about 68%, right?
Right.
How does that compare to the empirical rule?
It falls right on it. Very close.
Oh, so what's our answer?
See.
See,
That's the problem, that when I went to the example, to the help, obviously to give me the example of how to come up with that, they broke it down in that particular manner, and I racked my brains as how do they get 21? Where because they actually they did 21 to 34 to 37 and did 2, and then they divided by 120, which that's self-explanatory as well. But I was never able to understand how they got the number 21.
yeah,
And then
and that's, and so if this was 32 and they broke it down to 21, that's because they're taking out probably some of that.
right,
You know, they're doing an estimate of how many they think fall actually up here. I just took the whole number 32 and know
Right.
that that number is going to be inflated because I'm using a lot more than what I should have.
well, it makes sense. It makes sense the way that you did it, but I was never, I stayed on it for a long time trying to figure it out, and was never able
No
to figure it.
worries.
Now, I mean, now I could tell. I see how
Yeah.
when you came up with it, which makes sense.
So right here, it says between what 2 values would you expect to find 95% of the team? All right. So here I'm going to make a little picture based off of what we know up here. Okay, I'm going to draw my picture. And in the middle goes our mean of 688. And then we know that 1 standard deviation above is at 756. 1 standard deviation below is at 620. So this is what I'm looking at, and we know that our standard deviation, and again, our mean was 688 and our standard deviation is 68. So here's what I've written down and shown us. Their question is about if we're at 2 standard deviations. They want to know what are these numbers? That's the question. So how do we figure out those numbers? I'm going to figure out these two.
It's 556 and 824.
Well, how'd you get those, Ruben?
You add what is it, 68 to the 620?
Yeah, these are all jumps of 68. So add another 68 and we get the high number.
Number.
Subtract 68, you get the low number. So what were those numbers again?
556 and 824.
I like the 824. Check your 556 again.
-68. It's 480. It's 488. No, I'm sorry. It's
nope.
488. You're right.
Nope.
No.
Our low value there is 620. Take 620 minus
552.
552. Careful on that simple math of subtracting.
Yeah, that's right.
There you go. There's our two values. So in that first blank, our smallest value is 552. And in the second blank, our largest value is 824. That's where we would expect 95% of our data, because 95% of our data is 2 standard deviations. That's what they're asking about. Any questions on number 20?
What's the second part? 8, what?
Which one?
What was the values again?
So our first value was 552 and our second value is 824.
Okay.
All right. Number 20. So data on the residential energy consumption per capita measured in millions of BTU had a mean, so I'm going to write this down, a mean of 48.2 and a standard deviation of 18.9 for the states bordering the Pacific Ocean. Assume the distribution is approximately unimodal and symmetric. We like those. So they want us to find some information. So again, this question right here, part A, is very much like what we just did on 19 part C. So let's go ahead and make a nice little picture together. Who is in the middle of our symmetric unimodal?
48.2.
The 48.2, because that's our mean. When you're symmetric, the mean is in the middle. Okay. Let's go 1 standard deviation and then 2 standard deviations above, and we'll do 1 standard deviation below and 2 standard deviations below. How do I get these top values again? What are we doing?
You're adding these 18.9.
Yeah, every jump is an 18.9, either adding when you're going above or subtracting 18.9 when you're going below. So what is 1 standard deviation above?
67.1.
What is 2 standard deviations above?
86.
Okay. What is 1 standard deviation below?
Twenty-nine point three.
Okay, yeah. And what is 2 standard deviations below?
10.4.
Okay. So I think this is enough information. Let's go check out what we got to do. So it says, consider which 2 values you would expect to find 68% of the data. So we want those 2 values. We're going to round to 1 decimal place. Well, all of our answers were 1 decimal place. So that's good. And make sure that they're in order from smallest to largest. Small to large. All right. So where is 68% of my data?
Between 29.3 and 67.1.
You got it. So 68% is between 1 standard deviation, plus or minus, above or below. So that is, as Ruben said, 29.3 and 67.1. So those are what go in our blanks. That's part A. Let me move that down. Part B. So in these blanks, again, 29.3, 67.1. Part B says, where would we find 95% of our data? This is just like what we just did a moment ago. We did 95% of our data. Where is 95% of our data?
10.4 and 86.
Okay, because it's between 2 standard deviations. So that would be 10.4. And then I didn't quite hear the other one. I heard 6 something.
86.
86. There we go. And there's the other guy. 10.4 is our lowest. 86 is our highest for 95% of our data. Okay. So again, in this first blank, 10.4, 86 in the second blank. And I would probably put 86.0.
Yeah.
Okay. Let me double check something real quick. All right. It's weird because their answers are off than ours. Looking at that. It's weird. Okay. Not going to worry about it. I like what we're doing. So, part C. If a state on the West Coast had a per capita residential energy consumption rate of 5.7 million BTU, is that unusual?
Yes.
So 5.7, is that unusual? So that would fall right over here somewhere. Why is that unusual then, if you say that?
Because it's more than 2 standard deviations from the mean.
That's right. Unusual data points occur when you are more than 2 standard deviations away from the mean. So that is unusual. So 5.7 is definitely outside that. Which one would we select then? You said yes, so it's either A or C.
A.
A. Because A says that it is more than. All right. Hawaii had a per capita residential energy consumption of 22.3. Is that unusual?
No.
No, because 22.3 right up around in here. And is
Mhm.
that more than 2 standard deviations?
No.
No. So it's not unusual. So which one do we select, A or B?
It's A.
A again. So it is no, because it is not more than 2 standard deviations. Any questions on number 20? Can't stress enough, having a little diagram to help you out
Mhm.
helps a lot.
Yes.
All right, number 21. So the dot plot shows the heights of college women. Again, the mean is 64 inches or 5'4". The standard deviation is 3 inches. Complete parts A and B. So a little bit of math here. Do we really need the dot plot when talking about z-scores?
No.
No. That's just extra fluff and stuff. Okay, so let's talk about a z-score real quick, and then we'll get to this A and B part. So, excuse me,
Bless you.
a z-score. How do we figure out a z-score?
It's the value minus the mean.
That's right. Our number, our data entry,
Divided by the
Standard
deviation.
deviation.
minus the mean, which is what we call X bar, divided by the standard deviation. So that's what we're going to be using for part A and B. Yeah, it's too close together. So part A says, what is the z-score for a height of 73?
3.
So z-score 73. That's what we're looking for. So 73 minus 64. I almost put the number 3 there. And then you're going to divide that by 3. And they say to nothing about rounding. So hopefully these will come out nice and neat. Or if you get a decimal, you put it all. So what is the answer again?
3.
3.
But Professor, isn't the answer on the chart?
Oh, look at that. So they kind of put it down there, like 73 right there is up at 3. Yeah. It may not always be on the chart, just so you know. You should know that formula. Okay. But yeah, it is on the chart. It's right there. 3. So actually that kind of made this problem a little bit easier, but that's the mathematical way to verify it. So if it's not on this chart, you should be doing the math, which makes part B a little bit easier since we already have that on the dot plot. What is the height of a woman with a z-score of -2?
58.
58 right there. But let's verify that real quick. So let's work the z-score formula backwards. We know that their z-score is -2. What we don't know is the data minus 64 all over 3. How would we solve this?
We would multiply the -2 with the 3.
Yeah, you're going to do cross multiplying, which again is why all the way back on number 5, I talk about these as proportions, because that's exactly what you're solving here. This -2 is over what number? number is right here? Every number is always over a number. What is that number down here?
Is it 100%?
Nope. It's not a percentage. What is this number over?
1.
1. Thank you. Every number is always over the number 1. Okay. So all we're going to do is cross multiply and solve. So -6, because that's what -2 times 3 is equal to 1 times all of that is just x minus 64. And then now you have a small little equation to solve. All we got to do is add 64 to both sides. And now we can verify that 64 minus 6 is definitely 58. So if the z-score is not on like the picture that you see, this is how you solve it mathematically. It's just a quick proportion, cross multiply. Any questions on number 21? Okie dokie, artichokes. Twenty-two. An IQ test has a mean of 100 and a standard deviation of 5. They want to know which one is more unusual. All right, so we've got a mean of 101, a standard deviation of 5. So in other words, I want to look at two z-scores, a z-score of 91 and a z-score of 116 to figure out which one is more unusual. Okay, how am I going to know which one is more unusual? Once I know their z-scores, how will I know which one is more unusual?
One that's furthest from the zero, from the mean.
You got it. The one that has the furthest standard deviation score. Okay, so we're going to take 91 minus 101, divide that answer by 5. We're going to take 116 minus 101, divide that by 5. And they do say to, in the fine print, write integers or decimals rounded to 2 decimal places. Okay, so if you do any rounding, you round to 2 decimal places. So what is the z-score for 91?
-2.
Okay, nice integer. Or since they kind of talk about rounding, even though it is an integer, I would put 0.00. These 2 decimal places will become important for us later on. So I'm just kind of prepping you for what's to come. Because just saying -2, while it says integers is still correct, having these 2 decimal places, that's going to be important for us. So what is the z-score for 116?
3. 3.0.
3.00. All right. So who is unusual?
116.
The 116 is more unusual because it is the furthest away from the mean. It is the furthest away from the mean. So when we come over here, So are we gonna select A, B, or C?
A.
We're gonna select A. And then the blanks. So an IQ score of 116 is more unusual because its corresponding Z-score is
3.00.
3.00. It's the first blank. Is further away from 0 than the corresponding Z-score of, what's the other one?
Negative 2.00.
Perfect. There's your two blanks.
Professor,
So we'll select A, 3.00, and negative 2.00. Yes, Catherine.
so they do count this one if you just type the 2 or 3 right correctly.
And that's because it does say integers. If it just said 2 decimal places, definitely
Yeah.
put those in. But prepping you for what's to come for any stats class, when you're dealing with Z-scores, you definitely want the 2 decimals. It's going to be important.
Okay.
All right, 23. Oh, I can see the finish line. So assume the heights of women have a distribution that is symmetric in Newton modal. There is a mean of 67 with a standard deviation of 2.5 inches. So I got an X bar of 67. I've got a standard deviation of 2.5. Assume the men's height have a distribution that is symmetric in the modal. And all right, so I'm going to put W for these. So I got an X bar with an M for men that has a mean of 73 inches and a standard deviation for men of 3 inches. So we need to start doing some questions. So part A says the women's height corresponding to a Z-score of negative 1.08. Okay, so we got a Z-score and we want to know her height. So we don't have a picture this time to help us out like what we had earlier. But this is exactly like what we did earlier. It says write an integer or a decimal, do not round. Okay. So we have a women's height that is negative 1.80. Or sorry, a Z-score that is negative 1.80. We're looking for the height. So thinking back on what we just did, this is going to be equal to what? What does this piece look like over here? And this is just like what we did in, let me reference this real quick. Just like what we just did in number 21. What is this going to be equal to?
X
Mhm.
minus the mean, which is 67.
Because this is women
Yes, divided
all over.
2.5.
Okay. Again, what is that number over?
1.
1. Now you can cross multiply and solve. So negative 1.80 times 2.5. What do you get?
The answer is 62.5.
Okay, but what is negative 1.80 times 2.5?
Negative 4.5.
So there's multiplying these two. And then 1 times all that is just going to leave it alone. And then what do we do now to get to your answer, Catherine?
We add the 67.
You got it. And what did you get again?
62.5.
Perfect. Perfecto. So there's the answer to part A. The woman is 62.5 inches tall. Okay. All right. So we go back, see what the next question is. Professional basketball player, Evelyn. I'm just going to go Evelyn. I'm not going to even worry about the last name. Is 75 inches tall and plays women's basketball. Professional basketball player, Damon, is 79 inches tall and plays NBA, the men's league. So we want to compare these two and we want to know who is taller. Okay. What are we going to do first? So what should we be doing?
Draymond Green is taller
Okay. Why?
because he's past 3 standard deviations.
Oh,
He's,
Well-
he's above 3 standard deviations.
what about Evelyn?
Evelyn is past the 3, exactly. They both are.
Okay.
Um,
So you're saying I need to find standard deviations then. So what am I? So again, let's talk through. What do we need to do? How am I going to find standard deviations? What are we doing?
Z-score.
A z-score. We need a z-score. Okay. So let's talk about a z-score. So I need a z-score for the 75. I need a z-score
For the 79.
for the 79. So let's do those real quick. So we're going to take 75 minus the 67 and divide that answer by 2.5. And we're going to take 79 minus the 73 and divide that by 3. So what is Evelyn's z-score?
3.2.
Okay. What is Damon's z-score?
2.
So out of these, and it's kind of a bad question saying who is taller, but who is, you could say, for their division, the taller. That's what they're really trying to get at. You're comparing against divisions. Who's really taller?
Evelyn.
Evelyn. Evelyn is the taller. Because her deviation score is further away from 0 than his deviation score. So he is more, typical, where she is not. That's what they're getting at. So let's go through and let's answer some questions. So who is taller?
Evelyn.
Evelyn. So that's our first blank. Because blank, he or she. Say it again.
She.
She is blank standard deviations. How many standard deviations?
3.2.
3.2. And it does say integers are 2 places. I'm going to put 3.20 since it is an actual decimal, not an integer. 3.20. So 3.20 standard deviations above the mean for men or women.
Woman.
So there's our first 4 blanks. Evelyn, she, 3.20, women. While, who's the next blank?
Damon. Draymond.
Draymond. I think I called him Damon. Up here we have Damon and then it's Draymond. Either one. Draymond, green. Is only blank standard deviations. 2. And I'm going to put 2.00. But it does say integer, so it should accept the 2. Above the mean for blank. Men or women?
Men.
Men. There you go. So I don't necessarily say like who is, compared to his peers. Now that makes a little bit more sense. Compared to their peers, Evelyn is taller. So again, the blanks up here, this is 62.5. Down here for our blanks, Evelyn, she, 3.20, women. Draymond Green, 2.00, men. Okay. Number 24. All right. I'm gonna make sure this doesn't contain, nope. So name 2 measures of variation of a distribution and state conditions under which measure is preferred for measuring the variability. So I just need to name 2. So who are 2 measures of variation?
The quartile range.
So which one?
Is D. Sorry, I was
D
reading.
is one of them.
And G.
There you go. D and G. Because variation for our displays, standard deviation is variation when you are symmetric. Interquartile range is our variation when you are skewed. So those are the 2 variations. Okay. You don't talk about mean or medians because those talk about the center of the data, not variation, but the center. That's why I don't click on any of those. Don't click on C and don't click on E because those are about the center, not the variation. So we want D and we want G. Here it is, the last one, 25. We made it. There's a part A and a part B. So in your words, describe to someone who knows only a little about statistics, how to recognize when an observation is an outlier. And then tell us what actions should be taken with the outlier. So part A right here, let's talk about outliers. Which one of these is the best way to describe an outlier to someone who knows very little about statistics?
D.
B,
D. Letter
D.
D.
Okay.
D.
Okay. And I agree. D is what you're talking about. D is what we want. Okay. So obviously outliers are not maxes or mins. That's why you throw out A. Okay. They can be, but not every time is a max or a min an outlier. Part B is too technical. Your person that you're talking to knows very little about statistics. They are not going to know what an interquartile range is, or maybe even a median. Okay. C, so far so good, you know, but the problem in this one is right here. Outliers should be ignored. We don't ignore outliers. We want to investigate outliers. Okay. Outliers show us something that could have maybe been a mistake that we could correct. And if they're not mistakes, then it gives us a chance to look at our data in two different ways. So we don't ignore outliers. That's why C is wrong. D is the correct information. It's all very easy to understand. It's far away from your data. If I look at a histogram, there are spaces. They may not know what a histogram is. You could also just say like looking at bar charts, you know, they'd be like, oh yeah. Or say like a histogram is like a bar chart. They'd be like, oh yeah. Okay. And the fact that we want to look at them, they could be mistakes, or it may allow us to look at our data in two different ways. That's all very simple. I don't have to know much about statistics to understand what was just told to me about that. All right, the last one. So part B says choose the best answer below. It wants to know about resistant. Who is resistant when it comes between median and means? Say it again.
A.
A. Eh. Oh, sorry. Wait a minute. Hold on. Yeah, yes, it is A. Sorry, it is A. Although for me, B also, you know, it's pretty good that neither the number nor the magnitude of the outlier has any effect on the calculated value of the median, which is true. But right here is, this is what they say the answer is. Although I could really go for both of these. Okay.
Yeah, I remember on the homework I put B first, and
Mhm.
then it was A. But yeah, I
Yeah.
just went with it. But I also think B makes sense.
Yeah. The fact is really, you know, the median is the resistant one, and it's because of those outliers. So, and this should be a true case because your median is technically where the peak of your skewed data is. And if you took out the outlier, the median should still fall within that middle, that highest bar in your data. It should still be there. So again, that's why they like A a little bit better. But I mean, B, it's really, really close to this one. I could take it argued either way. So. But that's it then. There you go. That is exam 1.
Professor, the exam would also have 25 questions,
You bet.
and they will be closely related or similar to this.
Absolutely.
There won't be any outlier questions.
What you saw on here is what is going to be like what happens when you take the exam.
All right.
Any other quick questions?
Um, the exam, is it open next week or, well, I remember you said that
Hold on, I'll
It
talk
will
about
be-
that. Hold on, I'll talk about that in just a moment. Any questions related to the review?